sir.
So all the students of who are transferred from EC department to CS are present here.
Yes, sir.
Total 3 students.
Yes, sir.
So what are the roll numbers?
Sir, 82, 83, and
No,
86, I think.
individually responsible. Individually responsible. Roll number?
Sir, 83.
83. Next. Next. One more students will be there. Okay. Just some more students are present. Okay. Today I will include all the students. By the way, let us start this.
Sir,
Yes.
I have a doubt from previous module, sir.
Previous module.
Yes, sir.
Or module 2 or module 1?
Module 1, sir.
Okay.
So the question is,
Yes. Tell me. 82 स्कोर करने बोलो, ठीक है ना? हाँ बोलो, क्वेश्चन क्या था बोलो तो?
so the question is identify the valid conclusion from the premises.
Okay. So what is the propositions? Tell me.
So P and Q,
Okay.
if Q then R,
If P, then R. If
sir,
P, then
if
R.
Q then R,
Q R. Okay.
if P then M,
Then
and
M.
M not.
M not. Our question is.
Sir, options are P and R or R. Sir,
Send me
are
the
you
option.
writing?
Okay. Send me the option. Send me the option to the WhatsApp.
Okay, okay, sir.
Okay. In fact, send me the question in the WhatsApp group.
I'm sending.
Okay. Now let's start this topic. Okay, previous class we have discussed about this one. Okay, so you say what is the general form of the recurrence relations? Okay, today is third. Okay, so general form. Just recall this one. Okay, general form.
Excuse me, sir.
Yes.
Sir, I'm Ameya, role 82. Due to network issue, I was not able to connect. Can you please add me in the team?
Now presently you are in the team.
No, sir.
No?
I'm not added in the team.
Okay, I will add you. No problems. after the class.
Okay, thank you, sir.
Just a minute. Roll number is this one. Okay. I will add all of them.
Yes, sir.
By the way, general form, sir. Okay, okay, you can. So general form of recurrence relation. Today we are going to solve the uh, homogeneous linear recurrence relations. Okay. So it is written as C naught AR plus C1 AR minus 1. That's it. Hello. Hello. हाँ बोलिए मॉर्निंग में हाँ, अच्छा अच्छा हम्म, हाँ अच्छा 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 ठीक अच्छा अच्छा ठीक है हाँ 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 तो वो कितने बजे बोलेंगे बोलते हैं हाँ 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 वो एचओडी जो है मैडम है उनसे बात करते ठीक है उनसे भी बात हुई थी तो ठीक है दोपहर तक देख लीजिए फिर एक बार हम बात कर लेते हैं ठीक है जैसा और नहीं होगा तो फिर सिमरी में देख लीजिएगा ठीक है So next is CKAR minus K, and this is FR. Okay. So today we are going to establish the uh, find the solution of the homogeneous. Okay. So it is a homogeneous linear recurrence relation. This is the suppose I am giving it. It is a homogeneous linear recurrence relation. Okay. Now we know that for any non-homogeneous recurrence relations, we have two solutions. Previous class we have done this one. This is the solution. Okay. AR is equal to how much? AR is equal to AR homogeneous plus AR particular. Okay. If it is the homogeneous, then this terms becomes 0. You see, this is the solution. Okay. If this is for the homogeneous one. Okay. So if AR is the solution of the non-homogeneous linear recurrence relations type this. That means if this side becomes FR, then this is the solution. If it is equal to 0, that means we have, and this is the solution of the corresponding homogeneous. So actually this is the corresponding homogeneous one. So this part becomes 0. So what should be the solution? Solution of this is given by, if it is absent over here, then this is AR, this equals to ARH only. This is the solution. This will absent. Okay. So suppose like the different linear differential equation with the constant coefficients. So suppose let the solution let the solution of 1 be AR. Constant coefficient, that means we must have some constant here over here in the solution. Either this is 1 or some non-zero quantities, and suppose it is the alpha R. Okay, we are considering like this. It is the alpha R, suppose it is 2. Now put these values or substitute 2 in 1. Substitute 2 in 1. What happened? This A alpha R, this becomes C1 into A alpha R minus 1. This becomes C2 into, instead of this, we are adding A alpha R minus 2. So we are getting, okay, let us write this. A into alpha to the power R C1 into A alpha raised to the power R minus 1 C2 into A minus 2 and so on. CK, and this side is this equals 0. So in place. Now what we do, minus k, R minus k. Try to take this one as the common. Okay. R minus k as a common. Then this side becomes how much? C naught, and this is alpha R common. So we have a alpha to the power k plus k, it is minus 1. So this becomes the k minus 1. This is C k minus 2. And this becomes, now you see, we are taking non-trivial solution of the solution, non-trivial solution of the recurrence relation 1 given by 2. So this quantity should not be 0. This quantity should not be 0. So we can take this quantity, that means C naught alpha k C1 alpha k minus 1 ck, this equals to 0, and this is 3. So 3 is called characteristics equation. Characteristic equation. Okay, see, this 3 is called characteristics equation of whose? Of 1. 1 is the this equation. This is the 1, and 3 is the characteristic equation. So you see here, what we do, like ordinary differential equations with constant coefficients, of course that linear. So instead of AR, what I am putting here, x to the power alpha to the power k. Instead of AR minus 1, alpha to the power k minus 1, and like this. Is it clear? And this becomes as usual. So if it is the equation, then the corresponding characteristics equation will be this, simply by replacing alpha r by AR by alpha k. AR by alpha k. Is it clear?
Yes, sir.
So you should remember this one, and alpha, this is the one, and one thing remains, this is the alpha is said to be characteristics root. root. Okay, and this characteristic equation. So you see here the characteristic equation has a degree k, so it has exactly k characteristics root. Okay, so so you see here 3 has exactly k characteristic roots. Okay, the first one is right here. Now come to the conditions like ordinary differential equations, key characteristic root. If k uh, if k characteristic roots are real, and distinct. It may be when you are solving the equation number 3 of the characteristic equations, you get the different values of k. Okay, and these roots may be equals, may not be equals. Okay, and so suppose the districts. So suppose they are distinct, namely suppose alpha. Okay, you are solving in this in terms of alpha you are getting, and suppose these are the roots. Okay, these are only notations, nothing else. These are the different real but the distinct root of the characteristics equations. Then namely then you may write the solution of the solution of 1. So what is the 1? Homogeneous.
So C1 plus E to the power.
Mhm. Homogeneous linear recurrence relation is given by, you see here the solution all are written in terms of this homogeneous AR in terms of this. Actually this H represent homogeneous. Okay, nothing else. You may simply write AR. When you are solving the problem, you simply write AR. Now here we have to introduce constants also. Suppose this is A1, it is this is the alpha 1, A1 alpha 1 R. Okay, alpha 1 R, because our solution is taken to be this one. Okay, alpha to the power R. So we are getting different values of alpha. Now simply put it here, and by the superposition definitions or the concept of the differential equations, so we may write it this plus you may write A2 alpha to R. So this is the one of the solutions when we have this one roots are real and distinct. Okay, then your solution will be
Sir.
second. Yes.
So, but their
Yes.
solution was C1 e to the power x plus C2 e to the power 2x
No.
like this.
So that is in the differential equation. That is in the differential
Okay,
equation.
okay.
And this is the recurrence relations. Okay. next one is if roots are repeated. Okay, if the roots are repeated, okay, uh, repeated, that means this is, so what you write, let the root alpha 1 be a root of multiplicity m. Okay, multiplicity m, that means alpha 1 occurs m times. Okay, like double roots, alpha 1 occurs 2 times. It is also repetition, alpha 1 occurs 3 times. Here I am taking alpha 1 repeats m times. That means the alpha 1 has root has the multiplicity m. Okay, then the corresponding then the solution on the homogeneous solution is, I'm not going to establish this one, procedure is same. This is like suppose it is A1. Okay, repetition m times, so this should have m minus 1 times. Okay, plus am, m minus 1 to r, this is k, and this is alpha 1 r. And now next you can write it am. Now you can write a1 a2. Other roots can be written in these forms, like suppose b1 and it is alpha 2 r plus b3 b2 alpha 3 r, like this. Okay, so I am not writing this one. I am writing only the solutions for alpha 1 only. Alpha 1 repeat itself m times, or the multiplicity of the, this is it clear? So you see here, if it repeats, so you see, this is the solution. Okay, is it clear? Any queries?
Yes, sir.
So here I am only writing the one solution. That means alpha 1 repeat itself m times. So I am writing for alpha 1 only. Okay. Apart from this, if we have some distinct root also, so we have to add in this way. So what we do here? We started from r. What is the power of repeat itself m times? So we started from m minus 1 and goes to r to the power 0. Okay, and what is this alpha 1, alpha 2, or alpha k? What are these? These are the constants. How can you find these constants? Like ordinary differential equations, we can find this constant using the initial condition. Okay, so now this is the you see in your just a minute. Yes, you see here and recurrence relations. You see here, it is the classification of the recurrence relations. That means homogeneous and non-homogeneous recurrence relations, and their solution by the characteristics roots method. So we are going to solve the problem using the characteristics roots method, but for the homogeneous, still not for the non-homogeneous. So for the homogeneous, today we will discuss how to solve it. This note is sufficient for this. Okay. Now, what is the working procedure? Uh, Working procedure. So, working procedure to solve homogeneous linear recurrence relations. Yes. What is the question? Tell me.
What? How we will find the
Any
value of
queries?
m? How we will find the value of m? Sir, what
M.
is m? What is
M
m
is the
here, sir?
multiple. Suppose we are solving a different equation. Suppose a x cube plus bx square plus suppose cx plus d. Suppose cubic equations. Okay. So it has the solutions. How many solutions? X1, x2, x3 solutions. Okay. Suppose x1 is equal to x2 and this is x dash. Okay. So this x dash, that means this solution x1 and x2 repeats, or the x1 repeats how many times? If suppose roots comes 2,
One.
2, 3. Okay. So 2 repeats how many times? 2 times. So m is 2 over here. Alpha 1 is 2 and m is 2. Okay. Suppose it is 3. So 3 repeats 2 times. So alpha 1 is 3 and m is 2. Uh, Let
Got it.
alpha 1 be the root of multiplicity m. Multiplicity m, that means alpha 1 occurs m times. 3 occurs 2 times. 3 is the root which occurs 2 times. So m is 2 and alpha 1 is 3. Okay. Now working procedure. You should write this one.
Excuse me, sir.
Yes.
Sir, can you please explain this part again?
Which part? This multiplicity.
Sir, the root. Yes, sir.
Multiplicity means the how many times a particular roots repeat itself. If you are solving a suppose if you are solving a algebraic equation this, okay, of kth degree solutions, then what you will get? You will get the solutions suppose k1, k2, kn. These are the solutions. Suppose there are two
Yes, sir.
possibilities. Either all are distinct. Okay. So what is the pk? Pk is nothing but this one, this 3. Okay. So suppose, so either all are distinct. If all are distinct, then this would be the solution. This would be the solution. If some of them are, suppose k1, k2, k3, km, all are equal, and suppose this is equal to k, and then km plus 1, km plus 2, and kn. So we have, still we have a n roots. Okay. But out of these n roots, m roots are equal. So what is m is the, then what should be the solution? Solution for this is equal to how much? Alpha 1 r to the power m minus 1 plus alpha 2 r to the power m minus 2, and this. What is the r? R is the subscript, whatever given in the question. Okay. So k is the root. Sorry, alpha 1 is the root. What are the roots? This is k1. K1 repeats itself how many times? M times this. Multiplicity, that means how many times it will repeat itself. That is your multiplicity. It is not a new term. Is it clear?
Yes, sir.
So next is the working procedure, and you say write down this working procedure. So how to write the to obtain the characteristics equation. And solution of part corresponding recurrence relation with okay. So what we do, we particularly consider for particular degree. Suppose it is I'm taking for suppose third degree. Okay, so first one is this is a prototype. It is an example. I am considering here third degree. So first one is find the. These are the steps. Okay. So find the order of the recurrence relation. So what should be the order? If it is the third degree, that means occurrence relation is of order 3. If it is a third degree equation, characteristic equation, that means the recurrence relation is 3. So we will start from here. First one is okay. Next one is then what we will write? Take any variable, and here I am taking alpha, and substitute. If it is a third degree, then we'll start from alpha cube. If it is the fourth degree, we'll start from alpha to the power 4. Alpha for AR minus 1 and AR minus 2 respectively. Where? In characteristics equation. Relations or equation, whatever may be, which gives the equation you write. F alpha, that is 0. Okay. Third, simple thing. Once you are getting, solve for alpha. Okay. Say you are getting solve this one. Solve for alpha. You are getting alpha 1, alpha 2, alpha 3. And then conclusion part. You made it. Then the corresponding solution, or then the uh, homogeneous solution I'm writing, or the corresponding solution of the homogeneous recursive. Homogeneous solution is given by what? Uh, First I'm considering distinct. So this would be AR, A1, alpha 1 R,
A2 alpha 2
A3. I'm considering only 3. So A3, alpha 3 R. Okay. So if alpha I are distinct, I that means 1 to 3. Okay. There. This one. A I'm writing. Okay. And B is if alpha 1 is equal, I have taken the 2 only. This is alpha. Let. Then AR should be how much? A1. Now you see, compare with this one. M minus 1. So how much it is? M is 2 here. Alpha 1 is equal to alpha 2. That means alpha 1 repeats itself 2 times. The multiplicity 2. So 1 is A1 R 2 minus 1. And second is A2
1.
R 2 minus 2. So one constant term, and in another we have R to the power 1 only. Okay. So solution should be like this. A1 plus
A2 alpha.
A2 alpha.
A1
Good.
plus A2.
No, A2 R, not alpha. We have R.
Okay, yes. Sir.
R to the power m minus 1. And now you have alpha to the power whatever may be. And alpha 1 is equal to alpha 2. This is alpha. That's why I'm writing here alpha here. You may write alpha 1 or alpha 2 also. No problem. And 1 is the distinct out of 3. So exactly it will come over here. A3 alpha 3 to the power R. Is it clear? So ultimately the
Yes.
final solution will be this. So these are, but one questions definitely comes from this. Okay. Now come to solve some problem. So today we'll solve only this part, and later we will discuss this homogeneous part also. So let's solve some problem. Um, Example.
So,
Smoke terms. Yes.
sir, can you show that
Yes.
slide with step number 2? I'll take a snap of it.
Okay.
The
Okay.
previous
At
slide.
last you will take the snap. At last you will take the snap. Okay. Let me complete it
Okay, sir.
first. So A
Yes.
R plus 2 plus AR plus 1 minus 6 AR. This is equal to 0. How to solve it? So solution. So characteristics equation. Characteristic equation is given by okay. So what is the highest one? You see. Find the order of the recurrence relation. What is the order of the recurrence relation? It is 2. It is
2,
2.
sir.
First one is R plus 2 minus R. So it is 2. Okay. Just a minute. 2 minutes. A minute. So it is 2. Then you start from here. Find the order of this. Take any variable alpha and substitute this for the AR. So AR for alpha cube. Okay. Now we are taking the third degree. We have the second degree here. So we'll start it from alpha square. So instead of this, I am writing here alpha square plus. Sorry, this should be minus. This is minus alpha, and this is 6. Exactly follow the steps. Okay, now solve it. It is how much? 6. It is minus alpha, then minus 3 minus 2. So you will get alpha minus 3 and alpha plus 2 you will get. Okay, so alpha is equal to 3 minus 2. So what do you see? Real and distinct. Distinct. So what should be the solution? Real and distinct, that means this is the solution. Okay, these are the characteristics roots. So therefore you may write it, the characteristic roots are the real and distinct. So therefore the required solution, the required solutions, this one, actually I want to write this ones, a1 alpha 1 to the power r. So here we have alpha 3 and minus 2. Okay, so what should be the solution? So
9,
required
9A1.
no 3
Three
a1
Okay, sir. A1
3
3
to the power
square.
r. Okay, 3 to the
Yes,
power
sir.
r.
3 to the power
R. Okay.
minus A2.
R may
9.
be any values. Yeah, minus, because we have, let me first write this one, A2 and minus 2 to the power
To the power
R. So
R.
ultimately you are getting A1 3 to the power R minus A2 into 2 to the power R. Now this is a primary problem. So initial conditions is not here. Initial conditions, we must have some initial conditions so that we can eliminate A1 and A2 also. Then you will get a particular solution. Okay, so this is the solution of the recurrence relations, this. Okay, you can check this one. This is AR. Okay, so simply put this value over here. Now r minus 1 is how much? 3 to the power r minus 1 or 2 to the power r minus, r plus 1. Put it over here. And for r plus 2, this becomes 3 raised to the power r plus 2, and here also 2 r plus 2. Okay, so put it here. And then just take the algebraic sum. You can see that this side also becomes 0. Okay. Let me solve one more problem. So everybody try this one. Example A r plus 3 a r plus 3 plus 9 a r plus 2 a r plus 1 plus 16 a r 0. Okay, try to solve this one. What is the degree of this equation?
3.
Out of
3, sir.
3. Good. Highest is r plus 3, lowest is r. So it is 3. Okay. So how you start it? The characteristics equation. Characteristics equation. How can you write it? Characteristics equation. Highest one is this.
Alpha,
So it is
Alpha cube
alpha cube plus 9
plus 9
alpha
alpha
square
square plus 24 alpha
plus
plus
2
16.
alpha. Yes,
alpha.
sir, 24
It is
alpha.
r plus 1 and plus 16. 0. Now try to solve it. Alpha. What we see here? How to solve it? 16, 24, minus 8, minus 8 plus 8. So minus 1 will be the solution, you see. So you may write it like that. Alpha plus 1. You can see that alpha equal to
Sir,
minus 1
minus
is
1 and
the
minus 4.
-1 and -4. So everybody got it. By the way, let's alpha equal to -1 is the solution. So one of the factor is alpha plus 1. So it is alpha cube. So that alpha is square. Now alpha is square and this is 9. So we must have some 8 alpha. And this is 8 alpha square. And this is 1 plus 16. This is alpha cube. Alpha 8 alpha square plus 9. Now 24 alpha. So 24 alpha. How will you get it? 16 plus 8, 24. This equals to 0. So implies you may write it alpha plus 1 and this is 4 square to 8. So this is alpha plus 4 square. So alpha is equal to -1 -4
-4
-4.
-4.
Okay, so characteristic equations. So what should be the solution? Solution should be AR. This is equal to A1. This is distinct, so it is -1 to the power R.
R.
Okay, and this is plus. It repeats
A1
itself
plus A2.
times. A1 plus A2.
R into
A1 plus into R into here -4. -4
-4 to the
occurs.
power R.
-4 to
It
the power
occurs 2
R.
times. So good. So this becomes how much? Minus A1 to the power R, or leave it. We should not let this because minus is present here. And okay, you may write it -1 to the power R as a common, and then you can modify this one. By the way, leave it. This is the solution.
Sir, A2, A3 should be there. Sir,
A2,
you
sorry,
wrote
sir.
A1 2 times.
Okay. A2, A3. Okay. So, okay, today again you arrange one more class, okay? Arrange one more class.
Yes, sir, I messaged you so about timings.
About times you are writing from 12 to 2.
Yes, sir, and 6 p.m.
Exactly tell me the time.
So you can take our class at noon or at evening, sir.
No, from 12 to 2, exactly tell me the time.
So 1 to 2?
Okay.
Okay.
No, sir, 12 to 1.
Let's you decide first, then you inform me.
So I will message you in some time.
Okay.
Okay, sir.
Okay. Let me take the attendance first.
Excuse me, sir.
Yes.
You can
Just
take the class 2:30 to 3:20.
अरे थोड़ा देर
You can
बाद
take the
मैसेज कर
class.
देंगे अभी जी.
DSD वाला क्लास नहीं होगा इसके कोई.
Okay, first you take the snap of this today's class. From here, third.
Taken, sir. Thank you, sir.
Just a minute. Let me take that.